The ideal potato for chip manufacturing is typically 7 to 9 centimeters long. It must have low concentrations. First, the produce is rigorously washed with high-pressure water, then dropped into these tanks, where agitation sensor.
To ensure consistent sizing, potatoes are routed over vibrating steel rollers. Smaller potatoes fall to
the peels, dirt, and raw waste materials are channeled by conveyors into collection bunkers. High-pressure water.
You should wash potatoes thoroughly, maybe even twice. This removes the dirt and excess starch, which is essential for
During the extensive washing phases, our state-of-the-art systems meticulously manage and recycle water.
The potatoes are transported using a combination of water flumes and conveyor belts, ensuring a continuous flow to the next stage of processing.
This industrial slicer uses a bank of rapidly spinning circular blades to process potatoes with incredible speed and uniform thickness. Red lasers continuously measure the wafer thickness down to the nanometer. This data guides the blue plasma etching beam.
Why must the potato slices be washed immediately after being cut?
Blanching briefly treats the potato slices with hot water. This deactivates enzymes, optimizing the texture and color before frying.
Designed for maximum output, these massive industrial fryers form the centerpiece of the production line, featuring automated controls and high-grade stainless steel construction.
We maintain a precise temperature of 350 degrees Fahrenheit using the digital controls. This ensures the oil consistently.
Large-scale operations typically use stabilized vegetable oils. Continuous filtration systems pump the oil through.
As the potato heats, the Maillard reaction transforms simple sugars and amino acids into complex flavor and color compounds.
Immediately after frying, the chips pass under infrared heaters on a vibrating conveyor. This process shakes the excess oil free. The technology uses precision air jets. As a defective chip is identified, the jet fires a burst of compressed air, shooting. The criteria for a perfect chip include a uniform light golden color, a distinctively crispy, bubbly texture, and an.
Step 1. Raw material inspection. Step 2. In-process quality control, ensuring standards are met.
To ensure no foreign objects end up in the final product, we use advanced metal detectors and X-ray sensors that scan packages for contaminants.
The cooling phase is critical. When the chips are properly cooled, the seasoning adheres evenly, preventing clumping and waste.
Rejected chips are simultaneously repurposed as animal feed and discarded as industrial waste sent directly to a landfill.
The infrared sensor monitors moisture levels continuously. The robotic arm performs gravimetric analysis.
As the lead inspector, I'm primarily looking for 3 things. Surface imperfections like scratches or stains.
How is the seasoning powder distributed evenly across millions of irregularly shaped chips? The adhesive layer wraps around the flavor particles, while microstructures anchor the seasoning matrix securely to the chip's textured surface.
Switching flavors requires a complete system flush. Any remaining salt and vinegar residue would compromise the BBQ batch.
This factory is dedicated to synthesizing quantum mint. Our robotic systems precisely extract. Seasoning is applied while chips are warm because the residual heat and surface oil help the spice granules adhere better, ensuring even coating.
The contrast is stark. The unseasoned chips maintain their pale yellow color, while the highly seasoned chips are coated in a
liquid flavorings are applied via a pressurized mist, offering a more uniform coating compared to the uneven dusting of traditional dry powders.
an intense sensory experience. The vibrant colors of the spices overwhelm the eyes, while the air is thick with
Precision nozzles apply an exact amount of seasoning, 0.025 grams per chip. Sensors vary.
Simple. Chips are vibrated into multiple buckets, each weighing the contents. The system rapidly calculates which combination of buckets.
Potato chip bags are filled with nitrogen gas instead of ambient air to prevent oxidation. Oxygen causes the chips to...
Our automated system prints expiration dates, batch codes, and timestamps at high speeds directly onto the metallic bags as they move down the line. As the layers compress, the UV protection layer immediately deflects harmful rays. Simultaneously, the oxygen barrier...
These automated arms are designed to neatly and rapidly pack the slippery bags of peas directly into the cardboard shipping boxes on the conveyor line.
The output speed of this line is 300 parts per minute. This rapid pace is maintained.
The automated guided vehicle transports the empty pallet to the wrapping station, where the robotic arm secures and shrink wraps the finished goods for transport.
Files. Our quality control protocols ensure that any packaging defects, such as unsealed bags or incorrect weights,
Our packaging features dynamic load balancing and impact-absorbing materials, ensuring stability even during intense...
The key futuristic elements are the advanced automation systems, utilizing synchronized robotic arms.
The combination of sterile cleanliness, reflective stainless steel, and brilliant white lighting defines the factory's advanced sci-fi atmosphere. How does the sheer, towering scale of the machinery impact our perception of a simple snack food? The smooth, rhythmic motion of the machinery creates a sense of order and mesmerizing precision that soothes the mind.
Acceleration is imminent. The sequencing lasers analyze my form. Ahead, the portal awaits. My destiny is about to be realized.
This massive food processing plant utilizes vast resources, leading to significant
Integrating renewable sources like solar power, implementing smart automation across the network, and utilizing advanced...
Artisanal methods provide superior flavor and craftsmanship that machines cannot replicate. Yet, our
Specialized maintenance focuses on condition monitoring. Using vibration analyzers, we detect potential failures in these pumps.
To optimize this process, we must focus on quality control first. Increasing efficiency there will accelerate the entire line.
The manufacturing of potato chips has evolved dramatically, from the manual labor of the 1950s to the AI-driven facilities we see today.
Through machine learning, the system constantly refines robotic trajectories, dramatically increasing throughput.
Get ready to see food like never before. We're going inside the mesmerizing visuals of giant food factories.
As you can see, the potato shortage has halted production, while the lack of affordable oil means these trucks aren't moving either.